everybody, happy Friday. Today we're going to review Unit 10. I realized that in Wednesday's video I called it Unit 9, so I hope I didn't cause any confusion. We're finishing Unit 10. We're going to review and have our test on Monday. So I said in the agenda post and also on the assignment that there is not enough room to do the work on here, so make sure you have a separate piece of paper. I have mine ready to go. Graph paper is always best, but if you just need loose leaf, that's fine. I know some of you have been doing excellent work, staying with everything that you're supposed to be doing, keeping up with the work and going above and beyond. Unfortunately, that's not everybody, so I am making this review required today. So make sure you show all of your work. We're completing this practice test together, and then when you're done, you're going to turn that in. So as long as, if you watch the video, you'll have all the answers. If you'd rather try it yourself and then submit it, that's fine too. But if you want to make sure you get everything right, then you want to do it along with me. Okay. This is basically exactly what the test will be like Monday. But slightly, I'm doing the review with you. It's a little bit harder than the test to try to get us ready. So for the first 3 questions, we're using this figure. Okay, this is parallel lines cut by a transversal. So for number 1, I'm sorry guys, I got a phone call and it cut off my video. So for number 1, which angle pair is a pair of alternate interior angles? So to refresh our memories, alternate interior angles are the ones that are on opposite sides inside the parallel lines cut by a transversal. So before we start this, I'm going to remind you on my paper here, and if you would like to sketch this with me as a review, you can. If you have 2 parallel lines cut by a transversal, okay, such as this, inside the 2 parallel lines here is what we refer to as anything being interior. Out here and out here are my exteriors. Okay, so inside the triangle we have, inside the parallel lines we have alternate interior angles, and they're the ones that form the Z shape. So they're on opposite sides, and we know that they're congruent. So those are 2 examples. And also, these 2 are also alternate interior. Okay? We also learned briefly about same side interior angles and learning that they are supplementary. Okay, now we had alternate exterior angles too. So they're the opposite sides outside of the parallel lines, and they were congruent. So those 2, and also these 2. Okay, and then the rest was basically corresponding angles. They match up on the same side. So if you were going to cover up this half, corresponding angles would be in the same spot, such as here and here. They match here and here, and then on the other side as well. Okay, so I know it looks pretty messy. Sorry about that. So let's go back to our problems here. So we're looking for pairs of alternate interior angles. So, like we just reviewed, we have a Z shape that could either be 4 and 6, or it could be 3 and 5. So we're going to see which one is given to us. I don't see 4 and 6 here, but I do see 3 and 5. So that would be my first choice. Now for this second question, they're asking us whether or not the pairs that are given are corresponding angles or not. So we're going to check each one at a time. 2 and 6. So let's look at angle 2 and angle 6. Are they corresponding? They're on the same side and in the same spot. So yes, they are corresponding. 4 and 5. Let's check 4 and 5. 4 and 5. They are on the same side, but they're not in the same spot. It would be 4 and 8. These are same side interior angles not corresponding. So that's a no. 5 and 7. 5 and 7 our vertical angles, they're not even on the same side as the transversal, so that's a no. And then 4 and 8. Let's take a look at 4 and 8. 4 and 8. They're on the same side and they're in the same location. So yes, those are corresponding. Okay. Now, for number 3, if we are given that measure of angle 8, no, we want to find, measure of angle 8, if we're given that the measure of angle 1 is 61. So they're telling us this is 61 degrees. They want us to find this angle. So how can we find out? There's a few ways we can do this. Actually, there's a number of ways we can do this. So one thing you can do is you can use your alternate exterior angles. We know that angle 1 and angle 7 are equal. And then you could use the fact that this is a supplementary pair to find angle 8. We could do it that way. So I know this is 61. And then I can find 8 by subtracting from 180. Another possibility is going this way. Corresponding angles are congruent, so 1 and 5 are equal. Okay. I could also do, there's so many ways you could do this. You can say vertical angles, and then you could say, you could find the supplementary, if you did the vertical angle way, 61 would be equal to 3, and then you would use one of these. And then another way you could do it is to find this supplementary pair here first, and then know that that's equal to 8. So there's so many different ways you could find this angle, and none of them are wrong. You just pick whichever way you like best, whatever you want. I'm going to do it this way just because I just feel like it. Let's find angle 2 by using the supplementary pair. So I'm going to subtract like this, and that's going to give me 119 degrees. So if angle 2 is 119 degrees, then I know that angle 8 is an alternate exterior angle. It's the same, 119 degrees. So the measure of angle 8, remember when you're writing your answer, you write the measure of angle 8. You're not just going to write 119, is 119 degrees. Okay, and that's your answer. Voila. And any way that you chose to find that answer is fine, as long as you arrived at 119. That's all that matters. I'm so sorry, my cats are crazy lately. So number 4, I'm going to get my scrap paper. We're going to talk about some angles in a triangle. So number 4, the measures of 3 angles of a triangle are given by 4x minus 1, 2x plus 1, and 6x. What's the measure of the largest angle? So this is what we did in our live lesson last week. That's the triangle sum theorem. Okay, I know that all of the angles in a triangle add up to 180, right? So 4x minus 1 plus 2x plus 1 plus 6x are going to give me 180 degrees. They're asking us for the largest angle only. So once I find x, I'm going to determine which one is the largest. Okay, so here we go. I'm going to combine like terms. 4x plus 2x plus 6x. Okay, so 6 and 4 is 10, and 2 more is 12, so that's 12x. Then I have minus 1 plus 1, that cancels out. So it's just 12x by itself is equal to 180. We divide both sides by 12. Grab your calculator. 180 divided by 12 is equal to 15. So x equals 15. Be careful, because we're being asked for the largest angle. Now, you can pretty much conclude which one will be the largest, but if you're not sure, you want to plug it into each one to make sure. So 4x minus 1 is the first. So we're going to replace x with 15. And again, just grab your calculators and plug everything in so that there's no mistakes made. 4 parentheses 15 minus 1 gives you 59. Okay, so that's the first angle. The second angle is 2x plus 1. Okay, so you plug in x, which is 15. 2 times 15 plus 1. This is going to be 31 degrees. And then finally, 6x, you're going to replace the x with 15. and that's going to give you 90. Okay, and you can always check your answers and make sure you did this correctly by doing 59 plus 31 plus 90, because it should give you 180. And then you know you're correct, and then you can say the largest angle, which is 90 degrees. Okay, so your answer is 90 degrees. So I'll go back to my test. The largest angle equals 90 degrees. Okay? Okay, number 5, we're going to find the value of h in the triangle below. So this is a similar triangles question. I'm going to set it up on my scrap paper by copying the diagram. Okay, I have a smaller triangle inside of a larger triangle like this. Okay, this height here is 9. This is a right angle. This is a right angle. This is h, which is what I'm looking for. This is 5, and this is 7. I need to find h. So we're talking about similar triangles here. So we are looking for a side. I know that similar triangles have sides that are in proportion. So I'm going to set up ratios. Now, what I do every time is I draw these two triangles separately, just so that I can see a little better. Okay, so I have 9, and then this length here is going to be 5 plus 7. That's 12. And then this is h, and the little length here is 7. So now I can set up my proportions. So I like to go, it doesn't matter if you go from large to small or small to large, whatever you feel like doing is fine. So just because I wrote this triangle first, why don't we do that? So 9, you match up the sides. The 9 matches up with the h, so 9 over h. So the ratio is the same. And remember, you stay in the same order. So if you do larger triangle to smaller triangle, then you stick in that same ratio. So you start with larger triangle to smaller triangle. And now we cross multiply. Start with whatever I have my variable with. 12 times h is 12h. I'm going to go over here. Is equal to 9 times 7, which is 63. This is going to give me a decimal, so we're going to divide by 12. And h is equal to, go grab your calculator, no room for mistakes, 63 divided by 12. 5.25. And that's your answer. Okay, so h is equal to 5.25. Okay, moving on. Number 6. We have a triangle XYZ and has angle measures of 62 and 55. We're going to decide if each of these examples are going to be an example of something similar or not. So, if we have the first triangle has 62 and 55, we know to make two triangles are similar if they have two angles congruent, right? So all I need is to know that two of them are congruent. And in order to do that, I'm going to need to know what my third angle is here. So over here on my scrap paper, let me do this here. I know that the first angle is 62 and the second one is 55. Okay, so that gives me 117. And I subtract this from 180. And I can see that my third angle is 63. So the possibilities are 62, 63, and 55. So if another triangle has two of these, we can conclude that they're similar. So I'll write those up top here so we can see 62, 63, and 55. So for the first triangle in A, it has 62 and 73. So these cannot possibly be similar because there's no way of having two angle measurements that are equal here. So that's a no. 55 and 63, that's two of the same, so that's a yes. 90 and 55, there's only one that's the same, so that's a no. And then 117 and 62, that's another no. It has to have at least two angles that are equal. Okay, moving on to number 7. We're going to find, I'm so sorry, the volume of this cylinder. And we're going to do what we did in the lessons where we're using 3.14 for pi and we're rounding to the nearest tenth. Okay, so we have, I'm going to show you the diagram here. As you can see, the diameter is 7.8, so we need half of that. So remember, grab your calculators. Don't let yourself make silly mistakes because you're trying to do things in your head. Just always calculate it to make sure. 3.9 is going to be my radius. So first, I write the volume formula for a cylinder, which is pi r squared h. R equals h equals. So we just divided that diameter in half to find the radius, which is 3.9, and the height is 12.4. So I'm going to plug it all in here. The volume is equal to pi is 3.14 times the radius, which is 3.9 squared, times 12.4. And we're going to plug everything in the calculator all at once using parentheses. 3.14 times 3.9 squared times 12.4 equals, and we get 592.21656, rounding that to the nearest tenth. My 2 is going to stay where it is, so it's going to be 592.2, and then just make sure you know what your units are. It's meters cubed. So I'm going to write that answer on my test. Volume equals 592.2 meters cubed. Okay. Number 8. We have a cone now. A cone-shaped paper cup is 2.5 inches high and has a diameter of 3 inches. What's the volume? This time they're asking to the nearest hundredth. So the volume of a cone is 1/3 pi r squared h. We do r equals h equals. So they told us that the diameter was 3. So the radius is going to be half of that, which is 1.5. And the height was 2.5. So we're going to plug everything in. The volume, I'm going to move over here because I'm just running out of space. So the volume is equal to, in parentheses, 1/3 times 3.14 times 1.5 squared times 2.5. And we're going to put it all in the calculator all at once. Okay, parentheses. Remember, alpha y equals, and enter. 1 down 3 over, parentheses, times 3.14 times 1.5 squared times 2.5. If you ever need to go back, just use your arrows. 2.5. Close your parentheses and equals 5.8875. Just be careful because in this example, in this question, we are asked to round to the nearest hundredth. So we're going to go here instead of to our 10th spot, and we're going to round this to 5.89, and that is inches cubed. 5.89 inches cubed. Okay. All right, and now finally for number 9, we're using 3.14 for pi, and we're going to find the volume of a ball with a diameter of 7 centimeters. I have space down here, so I'm going to use this now. Okay, I'm going to draw a little sketchy. The diameter is given. That's 7 centimeters. I'm going to do my little dots to show that this is 3-dimensional. Okay, the volume of a sphere is 4/3 pi r cubed. R is going to be half of 7, which is 3.5. and we're going to plug everything in using parentheses. 4/3, 3.14 times 3.5 cubed. Get the calculator out. Parentheses, alpha y equals enter. 4/3, close parentheses, pi, which is 3.4, times r cubed, which is 3.4. And remember, to get cubed, you do caret 3 and then get out of the out of the exponent by using the side arrow. Close your parentheses and equals. So that gives us 179.503 ... I think we may have done this exact example in one of the lessons. And rounding that to the nearest cubic centimeter, that means to the nearest whole number. So that's going to be, we're going to round this up to 180 centimeters cubed. Okay, so the volume is 180 centimeters cubed. Okay guys, so the back of the test, we have a diagram with parallel lines cut by a transversal. What's the measure of angle 7 if we're given that angle 1 is 71? These are alternate exterior angles, so they're equal. So this is going to be 71 degrees as well. No work required. So the measure of angle 7 is 71 degrees. Name all the angles that are congruent to 8. So this is going to be crazy. So all the angles that are equal to 8. I like to start with verticals. So I'm going to actually just erase this so that I can show this a little clearer. First thing I know, vertical angles just always come to mind first for me. So angle 8 is congruent to angle 6. So I'll write angle 6 first. Okay. Then I also know alternate exterior angles are equal. So angle 8 is also equal to angle 2. Okay. I also know corresponding angles are equal. So angle 8 and angle 4 are corresponding. So angle 4 is equal. And now we can start to make sure we didn't forget anything. So we have these two angles, which makes those two equal. So they can't be. Alternate exterior angles, good. So those ones have to be. And then vertical angles. So we've got everything. So angle 8 is congruent to 2, 4, and 6. What's another set of congruent angles? So you can name any other set here that you see as congruent. Let's go with 1 and 3, but you can literally name any others. So angle 1 is congruent to angle 3. You could also just write angle 1 and angle 3. Okay, and there's a number of possibilities here. For 13 and 14, we're looking at a triangle. We want to find the measure of DBC. That's in here. Okay, make sure you follow the letters so that you know which one you're looking for. So I'm going to use the triangle sum theorem, which is, I'm going to take it over to the side because I do have a little bit of room here. The measure of angle D plus measure of angle C plus the measure of angle DBC gives me 180, right? So I set it up like this. 65 plus 67 plus angle DBC equals 180. Okay, I add these two together. So you can use your calculators if you need to. Remember, there's never any shame. 65 plus 67 is 132. Plus angle DBC is 180. Subtract 132. And angle DBC is equal to 48 degrees. Okay? Then from there, we're going to figure out the measure of angle DBA, which is our exterior angle. So we learned our exterior angle theorem, that it's the sum of the opposite two interior angles. So angle DBA is equal to angle D plus angle C. So to find DBA, I just add them together. 65 plus 67, which we already found before was 132. So angle DBA is 132 degrees. Voila. Okay. Okay, now we're going to finish up here. A cylindrical metal tin has a diameter of 12 inches and a height of 4 inches. what is the volume rounded to the nearest tenth? So we did a cylinder problem already, so I'm not going to go through this one again. The same thing here. It's the volume of a cone, which we did already, and the volume of a sphere. Now, number 18 is a composite figure. So there's two separate figures that are given here. So two separate figures to make up one figure. Sorry, I'm trying to be as specific as I can. And I can't remember if this is on your test or not. I'm just going to do it just in case. Okay, so a composite figure is made up of the half of a sphere on top of a cylinder. So basically you have a cylinder like this, okay, and then you've got a half of a sphere, not the whole thing, okay? So the height of the cylinder is 8 inches, and the radius of the half sphere is 3 inches. Using 3.14 for pi, what's the volume of the figure to the nearest tenth? Now, I did say at the beginning of this video that this test is harder than the one that I'm giving you, so I'll be pretty much, I don't think that there was a composite. You know what, I'm just going to take a second to double check real quick, just so that I'm not giving you false info. So let me just take a peek. 7, okay, let's take a peek real quick. No, yeah, there is a composite. Okay, so let's continue with this. It's just slightly easier. Okay, so what we're going to do is we're going to find the volume of each piece and just add them together. So we can do the volume of the cylinder first if you'd like. 1/3, oops. Cylinder is pi r squared h. And I know that my radius is the same as the sphere, so that's 3. And the height is 8. So I'm going to plug this all in. This is 3.14 times r squared, so that's 3 squared, times the height, which is 8. And I'm going to plug it all into my calculator, as always. Okay, parentheses, 3.14, close parentheses, 3 squared, close parentheses, 8. 226.08. 226.08. I'm going to leave it like that instead of rounding right away, because now I need to find my volume of the half of a sphere. So to find the half of the sphere volume, I have 4/3 pi r cubed. I'm going to find the volume of the whole sphere, and then I'm going to divide that by 2 because I only have a half. Okay, so r is 3. I'm going to put everything in parentheses. 4/3 times 3.14 times 3 squared. Plug it into the calculator like always. Alpha y equals, enter, 4/3 times 3.14 times 3 cubed. And that gives me 113.04. And that is the volume of the entire sphere. But since I only have half the sphere, I'm going to divide that by 2. All right, in the calculator, if you ever clear your calculator and you need your answer back on a graph calculator or a scientific calculator, push second, and down here you see ants. That's for answer. Second answer. It'll bring you back, enter. It'll bring you back your last answer. And then you can use that, divide by 2. 56.52. Okay, so now I have the volume of the cylinder and the volume of the half of the sphere, and all I have to do now is add them together. So 226.08 plus 56.52, just plug it in here. You can add it to your previous answer. 226.08. You get 282.6. And I'm already rounded to the nearest tenth, so I don't have to do anything. That would be my answer. So I'm going to write 282.6 inches cubed. That's my final answer. Okay, guys? So I only didn't do these 3 in the interest of time because this is already a half an hour long video. So, and we did do them over here. Okay? So that's what you need to know for the test. It's going to be basically the same, like a mirror image of all the types of questions. So that's it. This will be the hardest one, but you've seen how to do it now, and you'll be fine. All right, guys. So make sure you upload your work. And if you need extra practice, you can go through previous lessons. You can go in the textbook and do the review. Anything else that you could think of. We also have, of course, iExcel, which is a wonderful resource for us. All right, guys, so have fun reviewing. You have the whole weekend to refresh your memories on all this stuff and be ready to take the test on Monday. Please don't leave it till the last second. It's due at 8 p.m. at night. That doesn't mean you should wait until 8 p.m. to do it, okay? I don't want to be getting tests at 10 o'clock, 12 o'clock at night. Please make sure you start your test during the day, okay? Have fun.